Okay, so hopefully you've gone through all of the practice exercises in your 2.7 notes, and you're on to the last couple, where the instructions are to construct each of the functions by identifying all critical points. Like it says, this part of the lesson, I guess, or this part of the unit, uses all of the skills that we've been building up to this point to deal with these quadratics. You need to factor, you need to use the quadratic formula, you need to complete the square, you need to change the form of things, you need to recognize all the intercepts. Everything we've talked about comes to play here. So let's start with the first guy, where I have f of x equal to x squared plus 10x plus 16. I need a bunch of information here. I need to find out what is my y-intercept. What are my x-intercepts, if there are any? And what is my vertex? And based on that, hopefully, I'll have 5 points, and I'll be able to sketch the graph, or in fact, even construct the graph of this function. Now, the easiest thing to find is the y-intercept. The y-intercept is just 16, the c value. We get y when x is 0, so if I do f of 0, I have 0 squared plus 10 times 0 plus 16, which is just 0 plus 0 plus 16, which is 16. So that's how I find that y-intercept. Finding the x-intercepts means finding the values of x, which when I put them into my function, give me 0 as an output. So it means solving the quadratic equation, x squared plus 10x plus 16 is equal to 0. If I want to solve that equation, I have a bunch of options. I can complete the square, I can use the quadratic formula, or, sometimes things are nice, I can factor and use the zero factor theorem. In this case, I can factor, because x plus 2 times x plus 8 is a factorization of x squared plus 10x plus 16. 2 plus 8 is 10, and 2 times 8 is 16. So this works out. And by my zero factor theorem, I know that x plus 2 is equal to 0, or x plus 8 is equal to 0. Which means that overall, x is negative 2, or x is negative 8. So what are my x-intercepts? My x-intercepts are negative 2 and negative 8. Okay, we're getting somewhere. The only thing left to do now is to find that vertex. And I'm going to erase what I have, not because you should erase it from your page, but just to give myself some more room to work. So let's find the vertex, and let's remember that in general, the x-coordinate of the vertex is negative b over 2a. That is to say, in this case, it's negative 10 over 2 times 1, because my b value is 10, and my a value is just 1. So negative 2 over 10 is negative 5, and I see that my vertex has an x-coordinate of negative 5. To find its y-coordinate, I just have to use the function. I just have to take f of the x-coordinate, because f of x is y. F of negative 5 is negative 5 squared plus 10 times negative 5 plus 16. Negative 5 squared is 25. 10 times negative 5 is negative 50. And so if I do 25 minus 50 plus 16, I'm going to get negative 9. And my y-coordinate here is negative 9. Okay, so I've now found all important and relevant information about my function. All that's left to do is graph it. And again, I'm going to erase what's here, but I'm not doing that because you should erase what's on your page. I'm doing that to just give myself a little bit more room to work. So finally, when I go to construct my graph, I'm going to use the 5 pieces of information on the board. I'm going to use the fact that my y-intercept is at 16 on the y-axis. I'm going to use the fact that my x-intercept are at -2 and -8 on the x-axis. And I'm going to use the fact that my vertex has coordinates -5, -9. Once I've done that, I can perfectly construct my graph by playing connect the dots. If I'm not bad at connect the dots, which I kind of was there, then I should get a very nice looking parabola to finish off. All this information is reflected in my final parabola. The y and x-intercepts and the vertex all show up in the picture that I draw. So there you go. There is one nicely constructed quadratic. Let's do another one. The next guy that I want to look at is g of x equal to 3x squared plus 6x minus 5. And I'm going to do the same sort of thing that I did on the last board. I'm going to find the y-intercept. I'm going to find the x-intercepts, if there are any. And I'm going to find the vertex, which is a point with the x-coordinate and a y-coordinate. The easiest thing to find is my y-intercept. It's -5. Great. Good place to start. Nice to have something on the page. To find the x-intercepts, I have to solve the quadratic equation 3x squared plus 6x minus 5 equals 0. Now, if I check the discriminant on this guy, what do I get? Quickly in my head, I get 96, I think. So that's a little bit troubling. 96 is not a perfect square. Let's use the quadratic formula to solve this. Let's take the fact that our x is going to be equal to the positive or negative square root of b squared, so in that case 6 squared, minus 4 times 3 times -5, all minus 6 divided by 2 times 3. Okay, that's a bit of a mess, but we can actually clean it up quite a bit. If we take 6 squared, we get 36. And if I do -4 times 3, well, I get 12, -12. And when I do -12 times -5, I get positive 60. 2 times 3 is 6. So altogether then, I have the positive or negative square root of 96 minus 6 divided by 6. Which is kind of a cool little result there, but unfortunately not an easy one for me to put onto a number line. So I should break out my calculator at this point, and I should figure out, first of all, what is the positive square root of 96 minus 6, and then take that whole thing and divide it by 6. And when I do that, I get 0.633. Or, if I do the negative square root of 96, and then subtract 6, and then divide by 6, then I get -2.63. And those become the x-intercepts that I want to deal with here. My x-intercepts are 0.633, or just about that anyway, and -2.63, or just about that anyway. Okay, awesome. That's great. Let's talk vertex. So now I'm going to use my known formula that the x-coordinate of the vertex, x1, is -b over 2a. In this case, that's -6 over 2 times 3. So -6 over 6, which is -1. What's my vertex? -1. That's not quite enough, though. I need to find the y1 value, which is just f of the x1 value. That is to say, it's my original function with -1 substituted in for x. And when I do that, I get 3 minus 6 minus 5, which is negative 8. Okay, so if we put this all together now, we can construct the graph we're looking for. Start with our Cartesian coordinates, mark our y-intercept at negative 5, mark our x-intercepts at 0.633 and negative 2.633. And then our vertex is at negative 1, comma, negative 8. Awesome. Having drawn those, we can carefully connect our dots and get that arm of the parabola and that arm of the parabola, and we are done. We have successfully constructed the graph of our quadratic. Okay, so that was a lot, but we got there. And the following questions in the section are exactly the same. If you have any questions about any of those and you want to maybe check your answer or something, feel free to let me know. But otherwise, following this process should help you out on all the questions that follow. Thanks for watching.